Now let's have a look at the sandwich theorem for computing limits. Let's say that the function f is between the function h and the function g, and I calculate the limits of h of x at x approaching x naught and equals L, and the limit of g of x approaching x naught is also equal to L. Then the limit, by the sandwich theorem, the limit of x approaching x naught of the function f of x is also equal to L. You can imagine that you have this thing here, the limit of the function h as x approaches x naught So the function is f is sandwiched between the functions h of x and g of x. This limit is L. And this is also L. So from here we deduce that the limit as x approaches x naught is equal to L. This theorem, the sandwich theorem, so this is called the sandwich theorem, is very useful when I want to calculate a limit which is not so evident to be calculated. It's not so obvious to calculate it. For example, the limit as x approaches plus infinity of sine x over x is equal to what? I know, of course, that the limit as x approaches 0 of this function is equal to 1. But the problem here is, for x goes to infinity, what happens with the sine function? The sine function is always bounded between -1 and 1, like that. So from here, I divide by x not different from 0, not equal to 0. I get -1 over x. Here I get sine x over x. And here 1 over x. I take the limit as x grows to infinity of -1 over x. So it's minus the limit as x grows to infinity of 1 over x. And this is equal to 0. The limit as x grows to infinity of the other function here, 1 over x, without the minus, this is also going to 0 as x grows to infinity. So from the sandwich theorem, the limit of the function sine of x over x as x grows to infinity is equal to 0. Let's see another one. Let's find the limit of the following function sine x over e to the power of x plus 1. What is this limit as x approaches to infinity? The sine x is bounded between -1 and 1. The y values, the amplitude of the function is oscillating between -1 and 1. I divide by e to the power of x plus 1. Take the limit as x approaches to infinity of the minus 1 over e to the power of x plus 1. So this the denominator blows up and this goes to 0. Similarly, for the other limit, I follow the same process. So from the sandwich theorem, the limit of the function sine x, the wave function over the exponential type plus a constant as x approaches the infinity, plus infinity is equal to 0.